Okay, so a couple of just like overall logistics for your test, which is Wednesday. You are covering 9-4 to 10-1. Okay, there's no calculators on this one. I will give you the calculator on lockdown simply to check some answers, but just the simple basic one, that's all you're going to get. You don't need it for anything, okay, nor do I want you to use it for things and then get wrong answers because you're using it the wrong way, okay? It is, shoot, how many questions? 11 questions? I'll recount, let you know. And I will post for you the answer sheet, like during my lunch. I haven't created, I just have to post it for you to print if you are taking this at home. Remember that we're on like a weird schedule for the rest of this week. We have A, C first. You're basically following a Monday order today, tomorrow, and Wednesday, but the times are a little bit different. They've been extended for A and C for the senior exams.
That's why I'm gonna leave.
Yeah, and then Thursday is like a regular Thursday, but then Friday we go back to Monday schedule. And it's half day, you get out at 12:30.
On what days is the like time different?
Tuesday and Wednesday. Oh, the time is different.
Wait, what do you mean like the time?
The time is different on all the testing. So did they start tomorrow?
Yeah, till next Tuesday.
Yeah, but not Thursday, right?
Why not Thursday?
Because you're coming during the normal lunch block times.
No, 'cause I feel like it's a weird time too.
And then Friday for sure is weird because the lunch blocks are at the...
No, because it's still the same time, it's still that 9, everything ends at 10:10.
So like the rest
I
of
have
the...
I have a picture.
I know, I have it too here. So the makeup is on the IJ day, which is the 18th, in class. So the I seniors will take it, the J seniors will take it, and then anybody that's out on Wednesday, whether it's for AP Lang or something else, you'll take it then. And then the rest of you, I'll find some way to keep you quiet and entertained, okay? All right, so 9-4, we actually took off the graphing, so you can actually cross right through it, okay? We're not graphing the 9-4, the T-chart is not part of it, okay? Eliminating the parameter, however, is, so this is we want to get rid of the T. So if I had x equals 3t squared, actually, let's say 3t minus 1, and y equals t plus 2, I want to solve one of these for t and then plug it back in the place of the other one. So maybe take the y, make it y minus 2 equals t, and then plug this in the place of that t. X would equal 3 times y minus 2 minus 1. X would equal y, 3y minus 7, okay? If it wants it in standard form like a y equals, I would have to solve that. I'd get x minus 7 equals 3y, divide both sides by 3. And I get y equals x over 3 minus 7/3. So that would be it in standard form if it's a line.
May I repeat that one more?
If this one's multiple choice, so you'll see it will solve for one of the variables and you'll just have to move it so that it looks like it.
Oh.
So like if you get to this part and you look at your answer choices and there's no x equals and there's only y equals, then you know you have to keep going with the y. I don't think they're both lines, but you get the point. Solve, plug back in, and then you'll see it. That one's multiple choice. And then finding the parametric equations given one parametric and one rectangular. I think this is your other multiple choice question. So this would be like you have a parametric like x equals t plus 2, and then the other one that is not parametric, x equals, I don't know, x minus 3. And so we're going to take the one that is parametric. If it wasn't already solved for that variable, I would solve it and I would plug it back into the other one. So y equals t plus 2 minus 3. Y would equal t minus 1. And then the answer here is both of those equations. The x equals t plus 1 and the y equals t minus 1. So you are creating the parametric equations there. One of them will have a t and one of them will not. You take the one that does have the t, solve for the other variable, Like this one's already solved for x. If not, you would have to solve for x. And then plug it into the one that doesn't have a t, creating the t for that equation. So again, those two, multiple choice. Questions on 9.4?
Leave that there for
Mhm.
2 more seconds.
Okay, then came 9.5. So again, we can cross through graphing and finding additional points. You're not going to graph just the coordinate point or find the additional representations. Okay, but we are going to convert from rectangular to polar and polar to rectangular. So if I'm going from rectangular to polar, then I have my xy and I want to go to r theta. R equals the square root of x squared plus y squared. And tan theta equals y over x. I'm going to end up doing tan negative 1 of y over x. You're going to get 2 answers based on your unit circle from there. And then you use the location of the original point to pick which angle. So for example, if I had negative 3, 3, let's say, as my coordinate point, my r is going to be the square root of negative 3 squared plus 3 squared, square root of 9 plus 9, square root of 18, which is 3 root 2. That's my r. The tan of theta would be 3 over negative 3, which is negative 1. And tan negative 1 of negative 1, I would look at my unit circle. So for sure you want your unit circle. And I would label the tangents all the way around. So if I looked at my unit circle, there are 2 places that tangent would be negative 1. It's going to happen at 3 pi over 4, and it's going to happen at 7 pi over 4. God bless you. So then I would look to where my original coordinate point is plotted. A negative x and a positive y is which quadrant?
Second.
Good, which means I'd pick 3 pi over 4. So the answer here, our theta, would be 3 square root 2, 3 pi over 4. And on Canvas, you're going to have to type that in. Let me shrink this down a little bit because I know I have to get the other stuff underneath it. So I would parentheses 3 SQRT, open parentheses 2, close the parentheses, comma, 3 PI/4. If I am typing it on Canvas, that's how I'm going to type that answer in. Please, 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 no spaces. What are we taking, like the 7th test? Let's see if maybe we can get it right this time.
Is there any multiple choice on the test, or it's all fill in the blank?
I already answered that question. There's multiple choice. The 9-4, those 2 questions are multiple choice.
Okay. Alrighty.
That's okay.
There's no testing or additional points for this one, right? That's
Nope.
what you said?
Yeah.
Okay.
Okay, that was rectangular to polar, and then we go back the other way, polar to rectangular. So this time you're given the r theta and you want to go to xy. The x is r cosine theta. The y is r sine theta. These are a lot more straightforward. You just have to know your unit circle coordinate points. So if I gave you like 2, and then 11 pi over 6. Pi over 6 is in my fourth quadrant. Coordinate point there is root 3 over 2 and 1/2. The x is positive, the y is negative, so it's negative 1/2. So I would get 2 times the cosine at 11 pi over 6, 2 times the sine at 11 pi over 6. So this would be 2 square root 3 over 2 and 2 negative 1/2. These cancel, I get square root 3. These cancel, I get negative 1. So if you're taking it in person, you would leave it like that right on your answer sheet. If you're taking this in Canvas, that would be SQRT3, comma, negative 1. The number next to the square root should be in parentheses. So whatever's underneath the root should be inside the parentheses. Questions on that one? All right, then came the ones that this is going to be a big chunk of your points. 3 graphs from this section, okay? There will definitely be a limison. You're going to get either a rose or a lemniscate, and then the circle. So again, you're definitely getting a limison. You'll either get the rose or the lemniscate, and then a circle. So the limison, remember, it's a plus or minus b sine of theta, or a plus or minus b cosine of theta. So when we are adding or subtracting a number separate from the trig function, that's what results in the limison. If the a over b is less than 1, then there's a loop. If the a over b equals 1, then it's the cardioid, or the heart-shaped one. If a over b is in between 1 and 2, then it's dimpled. Okay, it looks like a lima beam. And if it's greater than, actually if it's greater than or equal to, so this is not. That's just less than. So this is not less than or equal to. This is just in between 1 and 2. Not or equal to. If it's equal to 2, then it becomes convex, which is the one that has like a flattened side. So if it's a limison, you're going to obviously give me which type. So you'll say a limison with an inner loop, a limison cardioid, a limison dimpled, a limison convex. You'll tell me what the symmetry is. Remember, if it has the word cosine, and then r is not squared, so this does not apply when the r is squared. But it has cosine, then it's symmetric to the polar axis. If it has sine, then it's symmetric to the pi over 2. Again, unless the r is squared. That we'll get to when we get to the lemniscates. Then you're going to plug in your points. So I would say if it is the loop, you want to do your over 3s and over 6s. In the first and second quadrants, if it's got symmetry to the polar axis, because then you're going to flip it over. In the first and fourth quadrant, if it's symmetric to the pi over 2, because then you'll flip it over there. If it is one of the other 3, I would say you could just do the over 4s. And your quadrant angles. So the pi over 2, like those I would still add. 0, pi, and then pi over 2, or if you're going to the negative 3 pi over 2.
Mr. Professor?
Yes.
If we're stating the symmetry, can we say x-axis or y-axis? We have to use polar or pi over 2.
You could put x-axis or y-axis. I'm going to grade that by hand, so that's fine.
All right.
Yeah. And then obviously you're gonna graph this. So you're gonna get like these points, which I forget how many there are, but there's a good amount of points here. That you're gonna get some points for the symmetry, you'll get some points for identifying what type it is, you'll get some points for the plugging in of the points, and then the overall graph at the end. Do not leave this blank. That's the dumbest thing you can do, okay? Don't leave it blank. Then you've got your rows. So your rows is your r equals, still not r squared, but r equals, and then a cosine 2, this will be a number, or r equals a sine, and then again a number in between. Remember, if that number is even, we double it to get the number of petals. And if it's odd, that is equal to the n equals the number of petals. So odd we leave alone, even we double. And then the number at the front is your petal length. So if it's a rose, you're going to tell me, again, symmetry. How many petals it has, the length of the petal, and then I would actually plug that length back in to find the first petal and use your symmetry to find the other ones. So if my petal length is 4, I'm going to say 4 equals this equation, work backwards, find out where that's happening, and then you should be able to get your graph. If it's 4 petals, it's in the corners, or it's top, bottom, right, left. You'll figure that out by the symmetry and by one of the petals. If it's 3 petals, it's 2 in the top, 1 in the bottom, 2 in the bottom, 1 in the top, something like that. You'll have to figure it out. If it's a lemniscate, this is the only one that's our r squared. R squared equals a squared cosine 2 theta, or r squared equals a squared sine 2 theta. Now the number in between that theta and this trig function can change, and that makes it have more than just those 2 loops. We're going to stick to the ones that we went over, which is the 2 loops. So these look like an infinity symbol. Symmetry is different with this one. So the symmetry is the same here, but it's different with lemniscates. If it's got a cosine, then it's symmetric to the pole and the polar axis. If it's got a sine, it's just to the pole, not the pole and the pi over 2.
Can you show what it would look like?
Yeah, so this one is like this. And this one is either like this or the other way around.
Thank you.
You're welcome.
Switch rows here?
Mm-hmm.
And symmetry to the pole, is that like origin symmetry? Or?
Yep. So that's like the one on, like you look at the sine ones, the bottom little infinities, the top right to bottom left. If I folded it diagonally, then it would overlap. That's what that means.
All right, thank you.
You're welcome. So for these, you're going to do the same thing. You're going to find the symmetry, and then you're going to find the loop length. And this time, remember, we take the number that's here and we square root it. So if that was like, if a squared equals 9, then my loop length is 3. So we square root it. Where the rows, we don't have to square root it. The rows is what the number is at the front. The lemniscate, we square root it. And then we would again set this equal to that loop length. So I would take that 3, plug it back in for the r, find where the loop happens, and then use your symmetry to get the other loop.
Miss Chris Weiser.
Yep.
How do you know if when the symmetry is signed, if it's going to be tilted like this way or this way?
That's where you'll find your loop. So like let's say that this said r squared equals 9 sine 2 theta, right? So I know that my a is 3 because I square root the 9.
Yeah.
And then I would say 3 squared equals 9 sine 2 theta. 9 would equal 9 sine 2 theta. Divide both sides by 9. 1 equals sine 2 theta. So what angle has a sine of 1? Pi over 2.
Yeah.
Pi over 2 would equal 2 theta. Divide by 2. And it's at pi over 4. Now I know my loop is here, right?
Yeah.
Which means it has to be there.
Would you always end up with like just the number like 1 equals because when you
Yeah.
replace the R?
Same thing with a row. Same thing with the rows when you find the pedal. If you do it right, you're plugging in, it should always be 1. Yeah. Okay, and then the last one is the circles. Now I want to stress that this question is designed to save you time, not cause you extra time. So know what you're doing, and this question will take you 10 seconds. Not knowing what you're doing and having to plug in points, and you're going to screw yourself over for the rest of your test. Okay? The circles, again, should be easy. So if it is R equals whatever the number is, cosine theta, whatever this number is here, okay? If it's positive, if the A is positive, this is going to go to the right. If it's a negative A, this is going to go to the left. And A equals the diameter. Not radius, diameter. So from end to end, from 0 to that point is going to be your A distance. If it's positive, it goes to the right. If it's negative, it goes to the left. And if it's R equals A sine theta, if it's a positive A, the circle is above your polar axis. If it's a negative A, the circle is below your polar axis. And again, the A is the diameter. So this is your payoff of practicing these graphs, because if you know what you're doing, we have graphed each and every one of these things, okay? It will help you on your time. This is going to be your either time helper or time killer. If you don't know what you're doing and you're plugging in points, you're going to screw yourselves over. The only one you really need to plug in points for is your limison. The rest of them you should know based on what we've practiced and what we just wrote down. You just got to know what it means.
Wait, so we don't need specific points for the other ones, though, or do we?
If you set it equal to the length, you get that point. I would say if I had extra time, I'd check the other loop. I'd plug in the point at the other loop and check it, but you don't need it.
Because of the reflection.
Right. You're just hoping that all that's right. So like if you wrote down the wrong symmetry, now you've screwed yourself.
Yeah.
And you can check it by plugging in a point. Right. Yeah. All right, so questions on these. Again, you're getting, for sure, a limison. You're either getting a rose or a limnoscate, and then you're getting your circle. And the points are not even. The points for the circle is the least, and then the rose and the limnoscate's a little bit more, and then the limison's the most. I think it's like 12, something like that.
For those rows,
Yeah.
when we like go to plug in the pedal length, like we put it as R, right?
Correct.
And then what is that? That tells you what one of where one of the pedals is, right?
Correct.
And use the symmetry after.
Exactly.
Okay.
All right, then came 10-1. So go back. No, that's okay. Okay, so 10-1 has these things: the graphing of the point, the finding the distance to midpoint, and then the complete the square for the sphere. Those 4 parts. So the graphing, I'm going to give you a graph. I'm going to have plotted a point. So let's just say I went, so it's not going to show these, but I think it's a little bit easier to read on.
Are you writing right now?
Yes. Is it frozen? I can't wait not to Zoom next year. I'm so excited. We'll just go back to the regular complaining about the Wi-Fi. Okay, let's say 1, 2, whoops. All right, I'll be honest that I think that the grid that I give you on your test is a little bit easier to read than this. Like it's a little bit more back. But let's just say that there will be, and there will be 4 points floating on here. They're labeled A, B, C. They don't have the little scoops, okay? And then it will ask you to identify which point is which. So if it had said, what did I count? 1, 2, 3, 4, 5, 1, 2, 3, 4. So if I had said which one has the coordinate point 5, 4, 2, my answer should be A. I tried to make it pretty obvious if they moved back or up because that's confusing. They are in 4 different locations, like maybe one's in that first corner, left corner, back right, back left, so that they're hopefully not that confusing. But that's all the graphing would be. It's going to give you the graph. It's going to ask you to identify which letter matches which specific point. Then you've got one that's going to ask you for the distance between your 2 points. Remember, this is the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. That square root has to be simplified if that's an option. People lose silly points like that. So if I have the square root of 20, this becomes 2 root 5. If I'm writing that in on a canvas, it is 2 SQRT in parentheses 5. That should be an easy one. Just be careful. People make mistakes. People like add there instead of subtracting. Just don't make silly mistakes. You have your formula sheet so you can check it. Again, another Corona perk. The midpoint, we add the 2 x's, divide by 2, add the 2 y's, divide by 2, add the 2 z's, divide by 2, and we will enter that in as x, y, z, no spaces. Maybe I should just take points off for the spaces, then people would stop doing it. That's your complete the square. All right, then came your sphere. So the standard form for sphere is x minus h squared plus y minus k squared plus z minus j squared equals r squared. Your center, h, k, j, and r is the radius. These are the ones that you'll have to complete the square. So I don't know if these numbers are going to work. Let me just make stuff up. I don't know. Doesn't make sense. Okay, again, this is going to be either another time helper or time killer. We have done complete the square so many times this year that you should be pros at this. But if you are still trying to figure out how to do it, it's going to kill your time. So the first thing I'm going to do is group together the 2 x's, x squared plus 4x, and then leave that space. Group together the y's, y squared minus 6y, leave that space. And the z's, z squared plus 8z, leave that space, bump the 10 to the other side. Complete the square all 3 times. I made them nice and even numbers. Don't screw this up. 4 divided by 2 is 2. 2 squared is 4. Add it here, add it here. 6 divided by 2 is 3. 3 squared is 9. Add it here, add it here.
Are you gonna have complete square with like 2x squared or like?
No.
Maybe just x
Yep. Z, 8 divided by 2 is 4. 4 squared is 16. Add the 16 and add the 16. And then square root, sign from the middle, put it in the parentheses and square it. Square root, sign from the middle, put it in the parentheses and square it. Square root, put it in the parentheses and square it. This is 20, 30, 39. So that's going to be on your answer sheet. Like it's going to say show the standard form of the equation on your answer sheet. But then in Canvas, you're going to answer the radius, and the center. The center is -2, +3, -4. Be very careful with your signs. And the radius is the square root of 39. That's 3 and 13, which can't get broken down, so it stays exactly that way.